I mean, there's maybe more information than you needed to be reminded of in this first section here on lines. The three different forms of an equation. I know that I tend to think of this as the form of an equation, and if it's in some other form, I need to change it to that. Any of them are fine, and each of them have their values. This is the one we're most familiar with. If you have the slope and you know what the y-intercept, the initial value, we call it the y-intercept, but it's also the initial value, the value at 0, right, for any kind of a function. This application down here happens to have a y-intercept of 32 because if you set it up this way, if you set up Fahrenheit up there and Celsius down there, it's probably not great to do what I'm doing here is the variables you use are the units. So it's probably better to call it y and x, even though I think I used f and c down here. Using the units that you're using as the variables is not great, but whatever you do there, you have that point, and you have another point here at, oops, you don't have a point there, you have at 100, you have 212. If you figure out the slope there, that's 100. This is not the same scale vertically, but this is 180 if you subtract that. You end up with the slope being, and this is degrees Fahrenheit per degrees Celsius. When you think about the slope for something, think about what the units are as well. Don't just say that it's 180 over 100 or 9 over 5. When you divide those two things, 180 degrees Fahrenheit per 100 degrees Celsius, you end up with 1.8, and the units would be degrees Fahrenheit per degrees Celsius. That has meaning, right? Those units give that slope meaning. It's the rate that they change as compared to each other. For every 1 degree Celsius, you get almost 2 degrees Fahrenheit. If something goes up 1 degree Celsius, if you have a change of 1 degree Celsius, you have a change of almost 2 degrees Fahrenheit. That's what that slope means. If you want to find the equation in any form, you could do it this one and just substitute things in, which I did down here somewhere, I think. I guess I didn't. I'll go back up here. I mean, you can take that standard form and put in 1.8. And then put in a point, right? Put in 32 is 0. And then solve for b. I think if you work through that, you're going to get, oops. If you work through that, you get b is 32. Not much work to work through, but 1.8x plus 32. Or you could have it as 9/5 if you'd rather have it as a fraction. If you want to use the other form of the equation, this one, like general, you don't really use general too much. If you wanted to change that to general form, you can do that by just taking this and rearranging things. General form is essentially just putting this on the other side, right? So if you had negative 1.8x plus 1y equals 32, that's general form. If you want them not to have decimals, you could, of course, multiply it all by 10 and make it negative 18x plus 10y equals 320. You're not changing the relationship between x and y when you multiply an equation, which I'm sure you know. The last one is I think this is a useful one. Maybe not so much if you memorize this equation, but if you intuitively understand why it works, I think it's pretty useful. If we go and make some blank space down here. If you think of that equation looks like this, and anytime you have subscripts and all these different variables, it makes it look a lot more complicated than it needs to be. All that is saying is if you have the slope and you have the coordinates of a point, x1, y1, then you can just write the equation. Like if you have something that passes through 2, 3 and has a slope of, I don't know, 6, sure. Really actually, let's make it not quite so steep. Let's do a half. If you have, well, while we're being picky here, let's make the numbers actually different numbers. 4/5. If you have that, you can write it right away by just saying it's 4/5 x minus 2, okay, that coordinate, and y minus 3. If you have to memorize this, then maybe it's not so useful, but if you understand why it is, imagine if somebody says you have a line with a slope of 4/5, but before we consider that, let's say it just passes through 0, 0. If you had a line with a slope of 4/5, its equation would be y equals 4/5 x. Really, all this is doing, this form, is it's replacing y with y minus 3 and x with x minus 2. In grade 12 math, you study transformations and you learn that if you move this around, that's what that represents. Replacing x with x minus 2 is moving it 2 to the right, and replacing y with y minus 3 is moving it 3 up. So, I mean, that's all that equation is saying if I want it to pass through 2, 3 instead of 0, 0, I'm just putting this transformation on this equation, right? So if you understand it intuitively like that, there isn't much to memorize. Okay, that's all it is. You could take this one and multiply it out, expand this out, you'd get the other equation. Not the one up there, obviously, but the equivalent form of this. All right? So lines, I mean, understanding lines, because a lot of what we do in calculus is going to involve lines and equations of lines, finding lines that are tangent to curves, finding lines that are perpendicular to each other. Any questions about that? I'll throw this up here just so you can check. The last one, a few people asked about this. If you're trying to find that last one, find that where they're the same. There's different ways to obviously think about it. The way I think about it is, I know that this is the relationship between the two, but then if you're saying when they're equal, I write a second equation that just says f equals c, or x equals y. When you have two equations with two variables, your answer is a single point, right? So you're going to get a single value. It's a system, right? A system of equations is when you have two equations and you solve them together. This maybe doesn't even seem like a system because all you're doing is substituting the c for the f there. So you get c is equal to 1.8c plus 32. If you solve it, you get c is negative 40. Negative 40 degrees Celsius, that's where they're the same. Negative 40 degrees Celsius is negative 40 degrees Fahrenheit. That's the one temperature where they're the same. Above that, Fahrenheit's a higher number. Below that, Fahrenheit's actually a lower number. Right? Negative 80 Fahrenheit is colder than the other one, right? This goes down quicker if you're converting. That's probably about it for lines, unless anybody has questions.